Okay, so members, we are going to see now case 3 when we are given 3 points on the line. Now, when we are given 3 points on the line, what do you do? But don't forget to subscribe to the channel. Now, if you are given 3 points on the line, what you do is you choose any 2 points. You actually are like given 2 points because these 3 points. All we need a point on the line, so you can choose from these 3 and do the parallel vector on that line. So a parallel vector can get between these 2, or this and this, or this and this. You just need to get a parallel between any 2. So let me show you an example. So if I get my u between A and B, it means my u sits in A is 2 or 1. So start from here. My u from here is negative. This will be negative 8. Then this will be negative 6. And this will be 4. So that's my u. What if someone used the and what if someone said that u is the linkage between, now the linkage between C and A. So I'll get C minus A. My C is 6, 7 negative 1, then minus A, which is 2, 4, 1, which will be this minus this. It will give me a 4. Then 7 minus to give me 3. Then negative 1 to give me a minus 2. So members, now you always take this is the part that is studying here. Nothing is similar. But to start in all this, you can factorize out a negative 2. So when I factorize out negative 2, you see this will be now 4, this will be 3, and this will be negative 2. So you start which is the same as this. So always remember, you make sure that there is nothing common. So here is that they had a common factor. So you factorize out that factor. So it's that I mean a common factor. So it's that 2 was common to all of them. So when I factorize out 2, I get 4, I get 3, I get negative. So you always make sure that parallel there is nothing common. So it's that you cannot factorize anything here. So this one becomes the vector. So that's how we use. So that all these are adding 2 in them, you factorize it. They are adding the 3, you factorize out the 3, then you get the balance. So now this you see that they are the same. But this factor, this idea, you have to be with it. So now I take this I by vector. So now my u from here is this. So now the vector form. We said our vector form is always A plus lambda u, which will be now my A is what? My A is any point. Let me take 2, 4, 1. Then plus lambda u, this is the parallel. So that's my vector form. Then when I come to parametric, now I express this in the form of x, y, z. So the genome equaling to now here my equations are now, you take the x, so my x will be 2 plus 4 lambda, my y will be 4 plus 3 lambda, then my z will be 1. These are all the parametric equations. Then when I come to the Cartesian, from this you can get a Cartesian. If you take this instead and divide by the coefficient of lambda, so it will be x minus 2 over 4 equaling to y minus 4. When I take this on the side, divide by this 3 equaling 2. When I take this side, z minus 1 over -2, and that's the Cartesian form. So those are the three forms. Now here they are asking me, now here you're going to see how do you show that a point is on a line. Now, if B is a point on this line, then the value of this parameter, you know this parameter has changed by the way, of this lambda should be consistent or the same throughout the equations. What do we mean? We are going to see how we check that the value of that parameter is consistent. But here I say, now in examples, show that the following points lie on the line. Now so they are giving our line in a vector form. So I'm going to show for this, now you will do for these last two. Now, to show that of course, I first express this in the column form. So it's like my R now there is going to be 1, 1, 1. Of course, this is 1, 1, 1. Then plus lambda. This lambda then -3, 2, then 4. Now, after doing that, I think you start, I'm going now to another point. I want to show that this point lies on that line. So my point is A, which is 7, -3, -7. So it's that this is in the form of x, y, z. So meaning, I also can express this in the form of x, y, z. It's that now, x, y, z, because this is the general, will be 1, 1, 1 plus lambda -3 to 4. So from there, now you pick, you see that these are your values of x. Then these ones, you put them here. You see now? So now, you see now, you get these equations. So it's that when I get these equations, I'll be having now 7 equaling to 1 minus 3 lambda. -3 is equaling to 1 plus 2 lambda. Then -7 is equaling to. Now, I want to check, is the value of lambda consist all the same without? So it's not when I take this inside, I'll be having 6. When I take this inside, I'll be having 6. So from here, I have 6. When I take this, it will be 7 minus 1, divided by -3. So 6 is divided by -3. So that your lambda is -2. When I take this side, it will be now -4 divided by 2. So that your lambda here is also -2. When I take this side, it will be now -8 divided by 4. So that my lambda will be now also -2. So now this is what we call, what we mean by saying that the lambda should be consistent. What's the meaning? Means it should be having the same value. So see, from all these equations, this lambda is having the same value. So there, we say that lambda is consistent. Now then, I conclude that since lambda is consistent, then this point 7, -3, -7 lie on a line, this line, on a line. So that's how members we show that the point is on the line. Please try out these two. I wish you the best. Don't forget to subscribe to the channel. Sign out.